Hello, this is Dr. Hanaa Assil, and this is about alcohols. This is mainly for the AS Chemistry at Excel Unit 2, but you can use it as basics on reactions and characteristics of alcohols. So let's take a look at some questions and answers. First of all, let's review what we know about alcohols. We know that all alcohols contain OH, that's the functional group of alcohols. If it has one carbon, methanol, ethanol, propanol. Now I need to identify on which carbon the OH is, so I need to say propane 1 all. We count from the side that gives the lower number. So any OH on either side is propane 1 all. This also is butane 1 all. Now when the OH is on carbon number 2, that is butane 2 all. Now what would this be? Propane 2 all. We also need to classify alcohols as primary, secondary, or tertiary. We look at the carbon to which the OH is bonded. If that carbon is bonded to only one carbon, it's primary. If it's bonded to 2 carbons, it's a secondary. If it's bonded to 3 carbons, it is a tertiary alcohol. So let's try and classify these. Which one is the one on the left? We look at the OH is bonded to a carbon. Now that carbon is bonded to how many? 3, that's a tertiary. This one, the carbon to which the OH is bonded to 2, that's a secondary. This one, the carbon to which the OH is bonded to 1 carbon, primary. This one, bonded to 2 carbons, secondary. So we need to know how to classify the alcohols. So, for example, this is a typical question. He says there are 2 alcohol structural isomers with the molecular formula C3H8O. Give the skeletal formula of these isomers. So I want 3 carbons. It's an alcohol, so it has an OH. Now, I can either put the OH on one end, and remember this is a skeletal formula. That means we draw a line to indicate the bond between 2 carbons. How do we name this? This is 3 carbons, so it's prop. The OH is on one end. This is propane 1 all. And this is a primary alcohol. Now, what is the other isomer? I can either put the OH on one end or the OH in the middle. So in that case, it's called propane 2 all. Now that is a secondary alcohol. Which of the following is a tertiary alcohol? Let's try and see. 3-methyl butane 2 all. This is 3-methyl butane 2 all. This is what type of alcohol? This is a secondary. 2-methyl butane 2 all. Can you see this? 2-methyl butane 2 all. This is a tertiary. 2-methyl butane 1 all. That is a primary. 2,2-dimethyl propane 1 all. That is also a primary. So which of these is a tertiary? It is that second one. Okay. Then we have reactions of alcohols. One of them is oxidation of alcohols. We can oxidize alcohols using an oxidizing agent. Examples of oxidizing agents: potassium dichromate and sulfuric acid. And you should remember that potassium dichromate originally is orange. When it reacts, it becomes green. The other oxidizing agent is what? Potassium permanganate and sulfuric acid. These are acidified potassium dichromate or acidified potassium permanganate. You should remember that potassium permanganate is originally purple. When it reacts, it becomes colorless. Now, when we oxidize alcohols, the product depends on what type of alcohol are we talking about. So if we're talking about a primary alcohol, that means the OH is on one end. Now, if a primary alcohol can be oxidized to form an aldehyde, that functional group at the end where you have C double bond OH, that is an aldehyde. If I continue to heat the alcohol with the oxidizing agent, it will be oxidized to carboxylic acids. So primary alcohols can be oxidized to aldehydes. If further oxidized, it becomes a carboxylic acid. Now, in order to have an aldehyde, I need to distill the product as it is formed. So when we want an aldehyde, we heat the alcohol with the oxidizing agent, and in this kind of setup, which is simple distillation, as the product is being formed, it is distilled off so that it does not go on and form an acid. But if I want an acid, I need to heat the primary alcohol until it becomes an acid. We need to set up this kind of setup. This is called heating under reflux. So the condenser is now in a vertical position, and any alcohol, we need to do this because alcohols are volatile. So if I heat the alcohol for a long time, it would evaporate. This kind of setup prevents the alcohol from evaporation. As the alcohol evaporates, it is cooled and condensed and returned back to the flask so that we continue heating it until it is completely oxidized to acid. A secondary alcohol, if it is oxidized, it becomes a ketone. A ketone is something that has C double bond O in the middle of the chain. And remember that ketones cannot be further oxidized, so that's the end of that. If we're trying to oxidize a tertiary alcohol, we cannot oxidize a tertiary alcohol. There is no reaction with the oxidizing agent. So remember, primary alcohols oxidize to form aldehydes, and then further oxidation will give an acid. Secondary alcohols form ketones, no further reaction. Tertiary alcohols do not get oxidized. So a typical question like this: ethanol can be oxidized by acidified sodium dichromate to ethanol. Ethanol is the aldehyde. And then to ethanoic acid. The apparatus may be set up in two ways. So either we use the reflux apparatus, in which we have the condenser in a vertical position, or the distillation apparatus that distills the product as soon as. Describe how the reflux apparatus ensures that any ethanol initially produced is further oxidized to ethanoic acid. Remember, we said heating an alcohol would first change it into an aldehyde like ethanol, and then if we continue to heat it under reflux, it is further oxidized to ethanoic acid. Remember, this is the apparatus for heating under reflux. Please notice the condenser is in a vertical position, water goes in at the bottom, goes out at the top, and the flask contains something called anti-bumping granules. These are placed in order to prevent formation of large bubbles during boiling, so that it prevents violent boiling or splashing out of the flask. So this is the setup for the heating under reflux. Now, how does this ensure that any aldehyde formed is further oxidized? In the ethanol, when it is formed, it evaporates, is cooled, condensed back into the flask to be further oxidized to acid. Draw and fully label the apparatus that would be used to carry out the complete oxidation of ethanol to ethanoic acid. Again, we're being told to draw what? This setup for heating under reflux. Include any material that would be used to ensure that boiling is controlled and not violent. What is that? We said that is the anti-bumping granules. These are placed in the flask to ensure that boiling is controlled and not violent. Please learn how to draw this apparatus. The term reflux is best described as what? What is reflux? We said this setup is for heating under reflux. What does reflux mean? Reflux means continuous evaporation and condensation. Which of the following compounds could be oxidized to a carboxylic acid by refluxing with potassium dichromate and dilute sulfuric acid? So we want to choose which one can form an acid. And remember, we said the one that can form an acid has to be a primary alcohol. Secondary will not form acid, tertiary will not react at all. So we're looking for which of these is primary. So let's take a look at them. This one is a secondary, this one is a tertiary, this one is a secondary, but this one, where the OH is on the end of that chain, the carbon attached to the OH is bonded to only one carbon, that is the primary. So that is the one that would give an acid when heated with potassium dichromate. Which of these compounds would not produce a color change when heated with acidified potassium dichromate? That means, which of these would not react with an oxidizing agent? Remember, again we said, the alcohol forms aldehyde, the aldehyde can form acid. A secondary alcohol will form a ketone, and the ketone cannot be further oxidized. A tertiary alcohol does not react. So we're looking for something that does not react with oxidizing agents, so we're looking for a tertiary or a ketone. So what are each of these choices? Butane 1-ol and butane 2-ol. These are alcohols, primary and secondary, that would react. Butanal is an aldehyde. It will react. Butanone is a ketone, and we said ketones cannot be further oxidized. Ethanol can be oxidized to ethanoic acid. Give the formula of a suitable oxidizing agent and the conditions required. If I want to oxidize ethanol to ethanoic acid, we said which oxidizing agent can I use? Remember, we can use potassium dichromate in presence of concentrated sulfuric acid. This turns from orange to green. Using the symbol for the oxidizing agent as O between square brackets, write the equation for oxidation of ethanol to ethanoic acid. How do we write this in the form of an equation? Well, ethanol, we always write, and we are already given that it is C2H5OH, plus the oxidizing agent gives ethanoic acid, CH3COOH, plus what? Remember, it's plus water, and that means that I have added 2 more oxygens, so I need to balance it with 2 oxygens. Now, another thing, boiling point of alcohols. Remember that the boiling points of alcohols depend on the number of carbons. First of all, we know that more carbons give higher boiling point. But if we have the same number of carbons, then more branching has lower boiling point. So, to determine the relative boiling points of alcohols, first of all, more carbons, higher boiling point. More branching, lower boiling point. So, a straight chain would have higher boiling point than a branched chain with the same number. Okay, The reason that alcohols have higher boiling points than the corresponding alkanes is that, as we know, alcohols can form hydrogen bonding with each other. So when they form hydrogen bonds between their molecules, they need more energy to be separated. So compared to the corresponding alkane, the alcohol has higher boiling point. Now, some alcohols have more than one OH. The more the OHs, the higher the boiling point, since each molecule in this case can make more than one hydrogen bond. So, for example, which is the order of increasing boiling temperatures in these molecules? Of course, the one with the lower boiling point would be the alkane, and then the one that has one OH, and then the one that has two OHs, and then the one with three OHs would have the higher boiling temperature. Explain why 2,2-dimethyl propane 1-ol has a significantly lower boiling temperature than pentane 1-ol. Now, what's the difference between 2,2-dimethyl propane 1-ol and pentane 1-ol is that the pentane is a straight chain, while the 2,2-dimethyl propane 1-ol, it has the same number of carbons, but it is branched, and we said the branched has lower. Now, why does it have lower boiling temperature? Because it has weaker van der Waals forces, since branching reduces the surface area, so there is less contact between the molecules. So the molecules cannot be packed together very closely. But if it is a straight chain, then the molecules are more closely packed, stronger intermolecular forces, more energy needed to separate the molecules. What is the test for alcohols? Well, we have two tests for alcohols. Either we add sodium metal, this gives bubbles of hydrogen gas, or we add phosphorus pentachloride, PCl5. If we add PCl5 to something that has an OH, it would give white fumes of hydrogen chloride gas. Remember, these tests are the same for acids. They will do the same reactions with acids. So sodium will still give bubbles of gas with alcohols and with acids. PCl5 will give white fumes with alcohols and with carboxylic acids. So, if the question says, how would you test for the OH group in 2-methyl propane 2-ol without using phosphorus 5-chloride, phosphorus pentachloride? What is the other reagent that I can use to test for alcohols? Remember, it is sodium, so we can say add sodium, it gives bubbles of hydrogen gas. Remember that the PCl5 will give white fumes of hydrogen chloride gas, but here we're told not to use phosphorus pentachloride. Alcohols can be converted into halogenoalkanes. Write the equation for the reaction between methanol and phosphorus pentachloride. So if I want to change an alcohol to a chloroalkane, so I'm changing methanol to chloromethane, we can add PCl5. Please notice the other products. PCl5 with an alcohol will give the chloroalkane plus POCl3 plus hydrogen chloride gas. And of course, we said this hydrogen chloride gas is seen as steamy white fumes. Alcohols can undergo complete or incomplete combustion. Write the equation for complete combustion of hexane 1-ol. Again, complete combustion means, first of all, reaction with oxygen. And complete combustion gives carbon dioxide plus water. And please do not forget to balance. Then it says write the equation for the incomplete combustion of hexane 1-ol, which produces only carbon and water. Remember we said incomplete combustion could give carbon monoxide plus water, or just carbon and water. Here the question specifically states carbon and water. Again, we have to balance the equation. Remember, alcohols undergo nucleophilic substitution. That means the nucleophile, which is something that has a lone pair of electrons, attacks the slightly positive carbon because the COH bond, the oxygen, is more electronegative than the carbon, so the oxygen has a slightly negative charge. The carbon has a slightly positive charge, so the nucleophile, something with a lone pair of electrons, attacks the slightly positive carbon, and the electrons of the bond between the carbon and oxygen go to the oxygen. So this is nucleophilic substitution. It replaces the OH with something like a halogen, such as an alcohol can be attacked by a nucleophile because what? Remember we said the alcohol can be attacked by a nucleophile because the CO bond is polar, the carbon is slightly positive, and the oxygen is slightly negative. 2-methylpropane-1-ol has this skeletal formula. 2-methylpropane-1-ol can be converted to 1-bromo 2-methylpropane. So I can replace the OH with a Br. We said which reagents and conditions are needed to replace an OH with a Br. Remember we said KBr, 50% sulfuric acid, heat under reflux. That would change the alcohol to a bromoalkane. Linalool occurs in lavender oil. Describe a simple test to identify the two functional groups present in linalool. Give the reagents required and the observations you would make. Now, what are the two functional groups that we have? We have an alkene, double bond, and an OH, but that is what? That is a tertiary alcohol. So, which reagents would identify these? Remember the alkene, we add bromine water, it turns from brown to colorless or orange to colorless. What about the test for the OH? Well, I could use potassium dichromate normally for primary or secondary alcohols that would react, but for alcohols in general, primary, secondary, or tertiary, we use the PCl5, which gives steamy fumes with any alcohol, whether it's primary, secondary, or tertiary. Describe a chemical test that could be used to distinguish between these two compounds. Now, what is the difference between these two compounds? Both of them are alkenes, so we cannot use bromine water to distinguish between them, but one of them is primary and the other is tertiary alcohol. So that one on top is a tertiary alcohol. That is a primary. What can be used to distinguish between a tertiary and a primary? Of course, we cannot say PCl5 because PCl5 will react with both, but we can say potassium dichromate, sulfuric acid, heat, and we said in that case, the one that has a tertiary alcohol will not change. So the linalool, no change. The one that has a primary alcohol, which is geraniol, this will change the color of potassium dichromate from orange to green. The organic compounds react with hydrogen gas in presence of a suitable catalyst. Name a suitable catalyst for reaction with hydrogen. Of course, if I have an alkene and I react it with hydrogen, I need nickel catalyst or platinum catalyst. Complete the balanced equation for reaction of this with hydrogen. Remember, hydrogen will affect the alkenes. It will not affect the alcohol. So I need 2 molecules of hydrogen because I have 2 double bonds in the molecule. Write the balanced equation for oxidation of ethanol to ethanoic. Use displayed formula to show all bonds. Use the oxygen between square brackets to represent the oxidizing agent. Again, this is how we write the equation for oxidation of an alcohol. The other product, remember the alcohol, the ethanol is changing to ethanoic acid, and my other product is water. Please, if he says displayed formula, you need to use displayed formula showing all the bonds and all the atoms and all the reactants and so on. Ethanol can be oxidized to the aldehyde ethanol using the apparatus shown. So we said we can oxidize ethanol, which is a primary alcohol, to aldehyde. What class of alcohols can be oxidized to aldehydes? Again, remember, it is the primary alcohols that can be oxidized to aldehydes. Now, explain fully why ethanol rather than ethanoic acid is produced and collected when the apparatus here is used. Remember, we are using simple distillation to oxidize the aldehyde to acid because the aldehyde, when it is formed, it evaporates first. It has lower boiling point than the alcohol. It distills off first, condenses in the flask before being further oxidized. State the purpose of the part of the apparatus labeled A. We have A is an opening in the distillation. This allows gases to escape so that it prevents buildup of pressure inside the apparatus, so it prevents explosion. Again, write equation for complete combustion of propane 1,2,3-triol using its molecular formula. Again, if we have complete combustion, this gives carbon dioxide plus water, and we balance. Write a possible equation for combustion of propane 1,2,3-triol in limited supply of oxygen. We said limited supply of oxygen, that is incomplete combustion. This will give carbon monoxide and water, and we're asked to write what is the observation that we see when we have incomplete combustion. We see black smoke. Another example, paramethane 3,8-diol has 2 alcohol functional groups. Classify the type of alcohol group on the far left. The one on the far left is which type of alcohol? That's a tertiary alcohol. Then we're told to explain the meaning of functional group. Remember, a functional group is a part of the molecule that determines its properties. Complete the structure below to show 2 structural isomers which have the same number of alcohol functional groups and the same carbon skeleton. So we want to draw 2 more isomers of that one on the left. That one on the left has 2 OHs. So where else can I put the OH? Remember, we need to put it on a carbon that is different to that first carbon. So I can put it like this or like this. Write an equation for complete combustion of methanol. Under standard conditions, complete combustion is carbon dioxide and water. Identify 2 other products that could form if the combustion is incomplete. We said, what are the products when combustion is incomplete? This could be, we said, carbon monoxide, yes, and please remember, we can also form carbon. Phosphorus pentachloride can be used to test for OH group. Describe what would be seen when phosphorus chloride is added to butane 2-ol. Again, when we add the phosphorus pentachloride to an alcohol, what we see is steamy white fumes. Again, remember that when we react an alcohol with the PCl5, the OH is replaced with Cl. The other products are HCl and POCl3. Give the structural formula of the organic product which forms when butane 2-ol is oxidized. Where is butane 2-ol? This is butane 2-ol. We said this would be a secondary alcohol. When it is oxidized, it should form a ketone. Now, the diagram on top, that is the displayed formula of the ketone, but we are told to give the structural formula. Can you see how we write the structural formula? CH3CO, CH2, CH3. Ethane 1,2-diol reacts in a similar way to ethanol, but both alcohol groups react. Write an equation for the complete reaction between sodium and ethane 1,2-diol. We said sodium with alcohol, the Na replaces the H of the OH. Here we actually have two OHs, so we're going to replace both OHs, so that is our product. So, I hope this was useful to you. I hope that you now understand the reactions of alcohols, and thank you for listening.